All right, so let's take a look at 5.2. We took a look at polynomials in 5.1. We took a look at algebra tiles, the second half of 5.1, and we're going to use that concept again of algebra tiles to help us understand how to add and subtract, collect like and unlike terms. Okay, so the algebra tiles, I think, will help us kind of concretely understand how this works, and then we're going to move quickly away from algebra tiles because I think once you kind of get the hang of it and you're able just to look at the terms, you'll be able to know what are like terms and how to add and subtract them really easily. So this is the way I'm going to introduce this, though, with algebra tiles. So again, 5.2 in Pearson Math Makes Sense. If you have your notes package in front of you, we're going to start filling out some blanks and doing some examples. So using algebra tiles, we can see how we can form something called a zero pair, all right? A zero pair. Now, a zero pair is a pair of algebra tiles that, when combined together, give you 0. They exactly cancel each other out, okay? So here we see, in the first example, a -1 tile, that's this darkened square, and a +1 tile, that's the empty square. When those two come together, they form a 0. They cancel each other out, okay? So you have a -1 over here, you have a +1 over here. When they come together, boom, they vaporize. They're gone, okay? That's because if you think about it, if I owe you $1 because you lent me some money to go, buy a treat on a fundraiser day we had at the school here. I got a little bag of candy for $1, and I borrowed $1 from you for that. I owe you $1. When I give you your $1 back, we're even, right? Later, we're even. So that's what a zero pair is like. I owe you $1, but then I give you $1, so we're even. The same applies for the x squared tiles and also for the x tiles. So anytime you see a 1 positive and a 1 negative of the exact same shape, those cancel out to give you 0. All right? That's a very, very important concept. And of course, that holds true if we had, two positive x squared tiles, and then we had 2 negative x squared tiles, okay? However many number we have, as long as it's the same number, those are going to cancel out. So obviously, these two would cancel out, and these two would cancel out. So that would be a -x squared plus x squared plus x squared. And those would all cancel out. And I'm frozen. There we go. Sorry. Now you can see what I'm writing. Good. Yeah, if I'm frozen like that, if I'm writing and you don't see anything, you can say you're frozen. That happens all the time. I'm always going back and forth, so sometimes I just freeze your screen so you don't see what I'm doing in the background, and then I come back. So that'll happen. Okay, everybody understand that, though? Okay, zero pairs, very important. All right, so here's your notes, any two opposite colored tiles of the same size and shape have a sum of what? Have a sum of 0. Yeah, we'll put 0 here. We can combine these tiles because they are like terms. Yeah, like terms. So another way to think about like terms is if I have in my lunch, if I have 2 apples and 3 oranges, okay? Now, that's a lot of fruit for me to eat for lunch. I would never have that. But if I had 2 apples and 3 oranges, I don't have to say I have 1 apple and 1 apple and 1 orange and 1 orange and 1 orange. I can actually say with one word, really, I can group all the apples together. I have 2 apples. And then I can group all the oranges together, not 1, 1, and 1, but I can say I have 3 oranges. Everybody knows that. That's gathering like terms. That's what you can do with like terms. I can't say that I have 5 aporanges. Aporanges. That's a weird word. It's not a non-existent word, so I can't combine all of them together because they are not like terms. Does that make sense? If I had 17 pairs, I could say I have 17 pairs. But if I have 1 apple there, I can't say I have 18 parapples or something like that. I say I have 17 apple pairs and 1 apple. So you can only combine the like terms. All right. So like terms have exactly the same blank and blank on those variables. Now, if we're talking about the variables, the written polynomials, what do you think would go in these spaces right here? For variables and for the terms here, they have exactly the same variables, goes here, okay? So as above, I'll show you above, the like terms that we were able to cancel out in the zero pairs or combine in some way, okay? So these all have the same variable. You see that? They all have the same variable. They're all like terms. They have the same variable and the same exponent on those variables. Okay, so the same variable and exponent. Now, in like terms, the coefficients that are the numbers in front, when we are talking about like terms, the coefficients can be different, okay? The coefficients can be different. So again, I have a group of, I have one apple over here and I have two apples over here, all right? Because they're all apples, they're like terms, and I can gather those together. And I can say I have 3 apples, all right? So the coefficient in front of this group over here was a 2, and the coefficient in front of this one over here was a 1. They can have different coefficients, but they would both have to be exactly apples. Got it? Okay. All right, so here's an example, and I think I need to zoom in a little bit on here so you can see that in the back. But 4x and a negative 2x, okay, are these like terms? Well, they have the exact same variables in the two terms and the exact same exponent on those variables. So there's no number that's shown there, but it's understood to be a 1, right? So those are like terms. There's 4x's and then there's negative 2x's. So you have 4 of something and someone, owes 2 of the same thing. So together you have a total of 4x's plus negative 2 is 2x's, okay? So that's what you get when you actually combine those. Now, I don't think we need to actually add them here yet. We're just identifying that they are like terms. So this one, B, 1 and 8. These are both constants. Obviously, you can add 1 and 8. The variables, there's no variables on there. So if there was a variable, it would have an exponent of 0. So technically, it would the definition would hold because it would have the same variable and the same exponent. It would be, if you wanted to put a variable there, that would be x to the 0 maybe. And this could be x to the 0 as well. So they're like terms. So constants are also like terms as well. And finally, x squared and negative 3x squared. The coefficients are different, but they have the exact same variables and the exact same exponents on those variables. Any questions? All right. Okay, like terms can be combined or simplified. Sketch the tiles for the following like terms and cancel the 0 pairs. Okay, here we go. We're going to be adding them now. Now I did this up here with just like talking about x's as being some item that we have or O. But let's do this in tiles, okay? So 4x tiles, let's actually draw 4x tiles. And I'm just going to draw them like this. And then I have negative 2x tiles. So I'm going to draw 2 more x tiles that are shaded in. And 2x tiles that are shaded in. So that's 4 positive x tiles and minus 2 or negative 2 x tiles as well. So my pairs now, you see that these 4 tiles, 2 positives and 2 negatives, they cancel each other out. Okay? So sketch the tiles and cancel out these 0 pairs. So what am I left with once I simplify this? Well, I have positive 2x tiles, right? So that means that, as we said above, 4x plus a negative 2x gives you a result of 2x. Okay? All right. Just going to move that off to the side a little bit here so I have room to work for this next one. All right, so this one, 1 and 8. Now remember, the constant tiles are the little squares, okay? So I have 1 little square tile, and then I have 8 little square tiles here. So let's just take a moment to draw these. So I have 1 and I have 8. If I were to combine or simplify that together, I could say that I have 9 tiles, right? So I won't draw them all out again, but 1 plus 8 equals 9. Okay, and that's just so very straightforward. But you see how we have all the tiles. They're all the same size and shape, so we can simply combine them. And there's no zero pairs here, so we don't have to cancel anything out. Okay, everybody good with that? Everybody good with that? Like terms, okay? Algebra tiles. All right, what's next here? Okay, all right, so unlike terms, if we have unlike terms do not have the same variables and exponents on those variables. So you can have two terms that have x's in them, but if they don't have the same exponents on those x's, they're unlike terms. So they have to be identical. Everything other than the coefficient has to be identical, all right? So examples that are not like terms or that are unlike terms, x and y. Obviously, these are unlike terms. This is like apples and oranges, right? They're two different variables, so they're unlike terms. We cannot just combine them into one term. A 2x and a 3, okay? These are unlike terms because the 3 does not have an x like the 2 does. And an x and an x squared term, those are unlike terms, all right? Okay. Write a simplified expression for the algebra tiles below, and remember to remove the zero pairs first. Okay, so what do I have? I have, this is a negative 2, let's say x squared. So negative 2x squared is what I have here. I have a positive x squared here. I have a positive 4x here with these rectangle tiles. I have a plus 3, and I have a minus 2. You see that? So that's kind of the collection of what I have here. Okay, oh, that's kind of a backwards one. All right, so if I now go ahead and look at my zero pairs, watch what I'm going to do. I'm going to take this one and this one. Boom, gone. And I'm going to take this one and this one, gone, and this one and this one, gone. Do I have any other positive and negative identically shaped algebra tiles that I can zero off? Please don't think this. Oh, I have two positive x tiles here, and this looks pretty close to this, so maybe I can cancel those out. No, you can't. No, they have to be identical tiles. One needs to be shaded, one needs to not be shaded. That's a zero pair. So what do I have left if I were to simplify all of these together? Well, I have 1x squared left, so I have an x squared tile. I didn't cancel off any of the x's, right? So I have 4x, I have plus 4x. And then what do I have left for my individual? I have plus 1 there. Okay? I have plus 1. And if I looked at just the algebra part of it without looking at the diagram tiles, okay, I have negative 2x squared plus 1x squared gives me negative 2x squared. Oh, sorry, this is a negative. I forgot my negative sign there. That's a negative x squared. So negative 2 plus 1 is negative 1x squared plus 4x. 3 minus 2 is 1. Yes, don't forget the negative sign there. All right. How are we doing with that? Easy? 5 out of 5 easy? 5 out of 5 easy? Anybody 4, 3? What do you think? Okay. I'm seeing lots of fingers. That's good. Okay, good. All right, this is easy. All right. Maybe you need to speed up. Well, we're almost done. We're almost done. Okay, sketch the simplified expression using algebra tiles 4. Okay, so here's an example just like the one kind of we just did, except it just gives you the expression here. So let's sketch this together. Positive n squared. So I'm going to make some big n squareds here. These are my big tiles here. Big n squareds. 4 n squared. Okay, got that. A negative 1. Okay, so I'm going to put, I don't know, I'll put the ones over here. So I got a negative 1. I have a negative 3n, so I'll make 3 negative n's here. Those will be filled in. Okay. So just a reminder, you guys need to be doing this on your paper as well, right? I am giving you some marks for a completed notes package. So when you do hand in your homework, I'll be taking in your notes package as well. So I'll be looking for it to all be completed. So that's another encouragement for you to follow along your notes, write down the examples, draw all the same diagrams and pictures that I'm drawing. Helps you kind of stay focused there too. All right, what's next? Oh, I have negative 3, so I need 3 more little squares. okay, that are shaded in. Awesome. Let's keep going. I need positive 5 n's, so I need some of these n tiles that are not shaded in. I need 5 of those. Okay, and then I need negative 2n squared, so I'm going to put those over here with my other n squareds. They're shaded in. Negative 2n squared. Okay. All right. Do we have everything? Okay, so again, let's take out our 0 pairs. So here's a 0 pair. That's gone. Here's a 0 pair. That's gone. I'm going to take 3 negative x's and 3 positive x's, and I'm going to cancel all those out. So that's gone. And then I don't have any positive numbers. I just have negative numbers there. Okay, so this looks like what I have left. So this is a positive 2n squared that I have left. I have plus 2n and minus, sorry? And what? And then minus 4, that's right. Yeah, this one is minus 4. You're right. Okay, so 2n squared plus 2n minus 4. And if we look at just the expression and collect our like terms up here, you see how I have 4n squareds minus 2n squared, so 4 minus 2 is positive 2. That's where this comes from. Negative 3n plus 5n. Well, negative 3 plus 5 gives me positive 2. That's where this comes from. And then negative 1 minus 3 more is negative 4. That's where that comes from. So both algebra tiles and just from the expression, you should be able to now identify like terms and gather them all together. Okay? So just in summary, when you gather all this together, this is the result that you get. And here's a little explanation of what we kind of worked through. So each of these algebra tiles, the collected like terms, you can gather those and then write the simplified version. The other like terms, collect those, write the simplified version, and finally that. So it's just like adding integers, okay? Just adding integers. Okay, I am going to get you to work on this. This is sort of the last, I think this is the last little bit before I give you your assignment. So I'm going to give you 5 minutes to work on example 4. Do this yourself, please. And if you want to draw the algebra tiles, you go right ahead. The challenge is for you to do this without the algebra tiles, but if you still want to draw your algebra tiles for any of these, you go right ahead, okay? You go right ahead. I'll do the first one with you. And again, these are like terms here. They're both a terms, so I can simply combine the coefficients in front. So negative 13 minus 10. You think about your number line, here's a 0. You start at negative 13 and you subtract 10 more. Where are you now? You're at negative what? Awesome. Negative 23a is your answer. Yes, very, very good. Okay, take a few more minutes and go ahead with those. Okay, so there's the first 3 answers. Let's do the last 3 together. The letter D, J, and K, those are different, some different terms, but I do have the J terms are like terms, so I'm going to combine those. Negative 1 minus 3 is negative 4j. And then there's nothing to go along with the 7k, so you just rewrite the 7k. It doesn't matter the order. If you wrote 7k minus 4j, that would be totally fine. That'd be totally fine. I'll give you a little hint, though. Usually, if there's different variables and they're written in a polynomial like this, usually you go alphabetically if you can. So usually the A's are written before the B's, which I did up here, okay? And usually the J's would be written before the K's. That's kind of convention. That's normally how we do things. But at this point, I just want to make sure that you can gather the like terms properly, so I don't care about the order. We'll worry about that as we move closer, further into math. All right, 3x and 5x, that should be 8x. That's pretty easy. Oh, Q's and N's and P's. Oh my goodness, we have 3 different types of terms here. So I'm going to collect the Q's together. There's some Q terms here. So negative 1 plus 7 is 6 minus 8 should be, is that negative 2? Did you guys get negative 2Q? Okay, very good. And then the N and the P, those are unlike terms. So which one comes first in the alphabet? L-M-N-O-P. Okay, so I'll write the plus 11N next and plus 11P finally. Okay? So do you have something like that? All right, okay, so now, if I'm doing alphabetically, though, I guess I can't stop there, can I? Alphabetically, L-M-N-O-P-Q. All right, so let's be consistent. Let's do N first, then the P term. Uh-oh, that's not good. When things start disappearing, that means my computer's not liking me right now for some reason. Look at that. 11N plus, I'll go slow so I don't overwhelm the computer, plus 11P minus 2Q. Don't disappear on me. So alphabetically, again, I'm not going to mark you wrong if you don't write it alphabetically, but if you're wondering if there's a way, technically there is a way to do that properly. The N would go first, but. Okay, how we doing? Everybody 5 out of 5 here? Yeah, 5 out of 5, okay. Maybe some 4s or 3s, don't be ashamed. If there are any 0s, let's talk, okay? We'll talk after this. All right, but that's basically all that I've got for 5.2 that I need to show you. So I'm gonna give you your assignment here, which I think the space for that assignment could be on the next page.